Okay. Just getting back here after break. We did have a question. Cade asks, does forcing a tool change on a tool that is being used multiple times in a row cause the toolpath to output via the regular tool change block or the null tool change? For the start of the operation, it will output via the regular tool change post block. And we can see an example of that. Well, this will actually be a good place to recognize it. So if I enable force tool change, let's check this guy out here. Yeah. So we've actually got multiple chains in there. I want to simplify it just a little bit. Just to make it easier to see, really. So we're looking at the NCI data. By the way, 1050 line is going to start out every NCI file you see, and the 1050 line has the P header post block as the entry. So this is what kicks off the posting process. Typically, the first output that you see in your NC file is going to be from P header. Then we go through a bunch of what I like to term preparatory NCI block calls. This is all preparatory NCI data because it comes before the tool change. There is a mechanism in the post itself for compiling and outputting a tool list. And if that tool list is enabled, the output is calculated during the pre-read of the NCI file. And we'll talk about that later. But that tool list is created and held in a buffer, and then it is output between P header and PSOF. So P header, tool change if you've got it turned on, and then PSOF, which is the starter file. Between P header, which is 1050, and 1001, which is the starter file, we have a whole ton of NCI data. All that's happening here is that MP is reading these two-line sets of data, and it is setting values. That's all it's doing. So we are setting a whole bunch of predefined variables, like 1,000 of them. Because if you look, each of these lines has, 10 or 20, 15, it's a bunch of parameters. So we're setting all of these parameters. The 20,000 series is mostly tool information. So here's some stuff about the planes, and then all, the 2000 or 20,003, 20,004, 20,006, 20,007. This is all tool data. And then we get to the tool change. So this is the first tool change. And you were asking about force tool change. So now we go and we look at the motion. So this is the motion. Which is funny, right? Because, like, if you look at the NC file, all of this stuff is motion. Right? And then there's a move in here, which in this case is a null tool change because we haven't reposted it yet. And then there's more motion. Well, if you look at it in the NCI, that motion section is really, it looks pretty small in comparison. Okay, so but here's all the preparatory data. Here's the motion for the first operation. Then you'll notice that we have more preparatory info, but not as much. So we're not repeating the machine definition stuff. We are repeating the tool stuff. Okay, we are repeating the tool stuff, but then you'll see a 1000, which is a null tool change. And then there's another section, right? Part of this is going to depend whether it's a 1001 or a 1002 on the type of motion it's doing. If I go into this operation here, contour 2D, every time you output a depth cut, it is going to be output as a null tool change block of code. So in our case, we still haven't even gotten to the other operation. We're still processing the same operation. And you'll see that in the actual code here. Because here's that G3, which you can see in the NCI. So if we go back to the NCI, we go to that first 1001 section. Here's the 41. Here's the G3. So this is the G3 line. And this is the cutter comp on line. And you can see that after this G3, which is here, we've only got 1, 2. By the way, I'm counting 2 at a time. So this is 1 move. That's 2 moves. 3, 4, 5. 1004 is a dwell, and there's nothing there, so that doesn't count. Right? So we've only got 2, 3, 4, 5 moves after the first G3. And if we look at the NC code, there's the first G3, and then we've got 1, 2, 3, 4, 5. Okay, well, where'd all the rest of the stuff come from? Well, number one, depending on arc breaking, we may be actually getting multiple arc lines coming out. Then you'll notice down here we have the same kind of G41, G3, and then multiple arcs, right? Same kind of G41, G3, and then multiple arcs. And so what we're doing is we're processing a bunch of 1000 G codes, which is null tool change. But let's answer your question. As we scroll down there, 1000, 1000, 1000. This is the key for us, because 999, at least to easily see it, 999 is the start of a new operation. You'll usually get a 999 line between each op, but you're not going to get it for the null tool change. So here's the 1001. We come down to the end, you see we've got 1004, we've got 1011, but there's no 999. So we get down there, and there's the answer to your question, Kate. turning on that checkbox takes the first pass in that operation and just changes it from a 1001 to a 1002. Now, what we should expect to see, though, again, we've only got, a few moves, some preparatory commands, and then more NCIG code 1000s, because each one of those depth cuts is always a null tool change. Same with multipasses. So if I had a bunch of multipasses, let's I just posted a single operation. And yet, up at the top, I get my 1001. Yeah, it's a bad way to search. That way either. But trust me when I say that for each depth cut and multipass that we're outputting, we're going to get, here you go. You can really see it here. There's a pass. There's a pass. There's a pass. So basically, it's going to make its depth cut and make a bunch of multipasses, make its depth cut, multipasses, etc. Okay. So we've talked a little bit about post blocks. A post block is a labeled block of post lines that can be called by name. Post lines can produce NC output, branch based on conditional logic, perform calculations, call other post blocks, and trigger routines in MPDLL. The post block label that declares a post block begins in the first column. Post block labels usually begin with the letter P. Posts that are used for mill turn applications also have post blocks that begin with an L or an M. The post block label must be on a separate line before the post lines that are included in the block. The only other text that can appear on the same line as a post block definition is an optional comment text that follows the pound sign. Post lines. Post lines can start in any column except the first. Use consistent indentation to make the organization of the post clear. All post lines are considered part of the last labeled post block until another label in the first column is encountered. This label could be another post block, a variable label, or a post function declaration. Post lines consist of one or more statements separated by commas. For example, this post line contains several statements. If next op equals 1003, or this variable is not 0, if either of these conditions is true, we're going to output the statements on this line based on their modality or their whether or not they are forced. The first statement on the line, if next stop equals 1003 or tool change home, is a Boolean condition. The next three statements output the values of variables. The next two statements output string constants. And the final statement ends with carriage return line feed, $. Mathematical operators. The MP language supports a large number of mathematical and logical operators. Grouping, parentheses, okay, helps specify the order in which you want calculations to occur, and also helps with readability in some cases. Standard arithmetic, so addition, subtraction, multiplication, division. Comparison, equal to, not equal to. So when you have the left and right arrow characters facing away from each other like this, so left arrow then right arrow, that is Boolean not equal to condition. Less than, greater than, less than or equal to, greater than or equal to. And the Boolean, so the comparison means we are comparing numbers. Logical Boolean statements are used to separate comparisons. And, or is the pipe character, so and is the ampersand, I believe that is. And Boolean not is just lowercase not. While I'm thinking about it, because it just kind of popped in my head, there's a very useful website that I don't think is actually mentioned in the PDF documentation. There may be a like a sheet that's in the PDF that actually has a limited amount of this info, but I'll take you to the site because I think it's useful. AsciiTable.com. www.asciitable.com. It's a website that's been around for a long time, and it gives you the table and description for each of the 256 ASCII characters. ASCII stands for American Standard Code for Information Interchange, ASCII. Computers can only understand numbers, so an ASCII code is the numerical representation of a character, such as lowercase a, or the @ symbol, or an action of some sort. ASCII was developed a long time ago, and now the non-printing characters are rarely used for the original purpose, except when you are programming CNC equipment or doing communication over old networks. In these cases, these basically any of the characters below 32. 32 is the space character, and if you look starting with 32, then 33, 34, all of these are the printable ASCII characters. You will find a key on your keyboard that represents or can represent each of these, I guess, iterations of characters. The early ASCII characters, 0 through 31, most of the time you're not going to see them on a standard keyboard. Okay, but this is a very useful website. I would highly recommend that everybody goes to AsciiTable.com and set a bookmark. Do it in Firefox, do it in Internet Explorer, do it in Chrome, whatever you use for a browser. Write it down on a post-it note and stick it on the mirror somewhere or on the bottom of your screen. As a programmer, I am constantly going to this because I need some, device control characters. Like, shit, was that 17 or 18 or, shift in, file separator, group separator, use those sometimes. A lot, basically from 10 through 27 or so, and sometimes 28, 29, 30, and 31. A lot of these are used for older communication networks, and especially when you are encoding the end of a file or the start of a file, or the data is coming into your old machine and it needs to put it somewhere specific. There are codes that trigger some type of action to occur, and it's helpful to be able to reference this data. Any questions about ASCII Table? Okay. Let's see where we're at here. All right. Formula functions. Let's see here. You know what? We've only got about 20 minutes left, so we'll go ahead and split the video